This is a word problem again for an exponential function. What is given is a 30-gallon barrel is filled completely with pure water. Salt water with a concentration of 0.3 lb per gallon is then pumped into the barrel and the resulting mixture overflows at the same rate. The amount of salt in the barrel at a time t is given by this function. So Q is the amount of salt in the barrel at time t. So keep in mind, when I graph, my x-axis is going to be the time, which is the independent variable, and y-axis is going to be the amount of salt in the barrel, which is Q of t. Okay, where t is measured in minutes, so this is measured in minutes, and Q of t is measured in pounds. Okay, so the first question is asking how much salt is in the barrel after 4 minutes. So what I have to do is find what Q of 4 is. So just plug in the values. 1 minus e to the power of negative 0.01 times 4. Can use my calculator to find the value of it. So go back. 9. 1 minus e to the power of negative 0.01 times 4. Okay, 0.01 times 4. So this, it says round your answer to 2 decimal places, right? So the answer should be approximately 0.35 pounds. Okay. Okay, the second part of the question is asking me to find how much salt is present in 8 minutes. So again, finding Q of 8. So 9, 1 minus e to the power of negative 0.01 times 8. Again, I'm going to use the same input that I did, just bringing that up and just changing that number to 8. So the answer is 0. Again, rounding to 2 decimal places, 69 pounds. So this is 0.69 pounds. Okay. Okay, so the next part of the question is asking me to draw the graph of the function. So here it says draw the graph of the function, and I've been given few functions. So, but let me put my values in. First, I'm going to input the function 9, open parentheses, 1 minus second ln, which brings the e, negative 0.01, and instead of t, I have to use x. So I'm going to close the parentheses. Now, since they already gave me the graph, and I see 4 graphs down here, and if you look at the windows of the graph, the x minimum, y minimum is kept 0. X maximum in all 4 graphs is 100, so I'm keeping that 100. And y maximum in all those 4 graphs is 14. So I'm leaving the scales the same. Just graphing with the matching graph given to me, so it's easy for me to compare the graphs. Okay, so hit graph. Okay, this is explicitly saying this is the graph that I'm seeing. Therefore, the graph of this function is going to be this one. Okay, now I can do the previous 2 examples, like the previous 2 values after finding this also. Let me cross check this for you. Like finding this 0.35 lb when your t is 4 minutes and 0.69 lb when t is 8 minutes could be done from the graph too. So for that, what you can do, go second calc, hit value. So when x is 4, I need what my y value is. I'm looking for a 0.35, 3.352, which was the same thing I got the other way around. Again, if I want to find the second one, when x is 8, my y is 0.69, which I got the same one. So I checked these values, by 2 methods. I did it algebraically, and also I did it from the graph. Okay, so there's one more portion to this problem, that is the last piece, where it's asking, use the graph in part C to determine the value that the amount of salt in the barrel approaches as T becomes larger and larger. So what it's telling is, if this graph is going forever in this direction, what will this value approach? Okay, so the graph doesn't clearly show what is happening after the 100, right? But it looks like it's going to approach, in this case, 9. And how confidently can I say that is because of this equation. So my function is what? Q of t is equal to 9 1 minus e to the power of negative 0.01 times x. Okay, so if I think that if my x is going to, say, probably infinity, let me say if this is going to infinity, like to the right extreme, I don't know where, but it goes on forever, right? So if I say that's positive infinity, then look at this value. This would become 0. How? Because then it would be like 1 over e to the power of infinity, which is kind of writing 1 over infinity. 1 over infinity is 0. So I will have a 9 times 1 minus 0, which is a 9. So what's happening here is the graph is approaching. As it approaches, at 9, so it's going to go like that and kind of flatten it. And at 9, I'm going to have a horizontal asymptote. So the answer for this is 9lb. So I cannot see it very clearly from this graph because of the scales, but as it goes to the right extreme, it's going to approach 9. I double checked it in an algebraic way too.